Hi everyone, in this applet, we want to take a look at two individuals that are going to run a race, and their names are Torty and Harry. So if you know the famous fable of the tortoise and the hare, that's where these names are coming from. So Torty is like the tortoise and Harry is like the hare or the rabbit. So for a moment, I'm just going to look at Harry. And what's going on here is that we have a 3D surface, which is kind of cool. You can rotate this thing around. I'm just clicking on it. And so this race is not going to be run on a flat surface, right? This is a lumpy, bumpy surface. And so Harry, our rabbit, is going to run around. And the track that this individual is running around is this dark line. So as time progresses from 0, Harry's at the start, and as time progresses, we can see Harry start to move along the track. And we can see that one lap is done at approximately 2 pi, and if we keep going around, time equals 4 pi. Harry completes 2 laps on the track. Okay, let's take a look at what Torty's doing. So now I'm going to turn off Harry and just show Torty. Again, we'll start Torty at 0. And so Torty is scooting around. Those tangent vectors and unit vectors look a little bit different. I'll leave that for you to explore. But if you look here, it looks like they're both at the same place at 2 pi, and if we go around a total of 4 pi, again, we see that Torty has also made 2 laps. So if I had to make a conjecture about what happens from time equals 0 to 4 pi, I certainly know that they both start at the same point and they end at the same point. And if I watch them go around, I can see that at some point Torty is ahead, and then at some other points Harry is ahead. All right, and they're playing this little game. It seems that they're at the same position. It's a tie when we get to the 1 lap mark. It's almost like a Formula 1 race, you know. Around they go, so many laps. But anyways, we're only going 2 laps around this one. And again, you know, one overtakes the other and around they go. And at the very finish line, it looks like it's a tie. So that could be your intuition. But if you really wanted to make that statement with confidence, you could go ahead and compute the length of the curve that Harry travels around. If you had a vector valued function that represented Harry's path, you could compute the length of that curve from 0 to 4 pi. And then you could compare that to Torty's length of curve from 0 to 4 pi. And so if you find that in the same amount of time they went the same amount of distance, you could say that confidently that they tied the race. If you wanted to do those sorts of calculations, you can certainly try it by hand. It might get a little bit messy, so you might turn to a software or computer algebra system. I'll leave that to you. So this is the C Bliss Math channel here on YouTube, and I have a Calculus 3 playlist. Now, some of the section numbers correspond to a different textbook, but the topics are the same. So if you were to scroll down in here, there is a whole section on vector-valued functions. Really great videos in here. I think they're very clear and down to earth. And where I would draw your attention would be to the arc length of a vector function. So this video is by another presenter, Patrick JMT, and this presenter gives the formula, and they do a few examples in there. But if you wanted just a general introduction, you'll get to my videos as well. So you've got some options for extra resources.